first exoplanet found around a Sun-like star in 1995, astronomers detected a blisteringly hot Jupiter-mass planet orbiting closer to its host star than Mercury is to the Sun. This discovery recast our thinking of how planets form and led to a new era of exoplanetary exploration. Anyone over the age of 35 will remember growing up in a world in which only one planetary system was known, our own. We remember proudly reciting the names of the 9 planets, 8 before Pluto's discovery in 1930, and again today with its reclassification as a dwarf planet in 2006, and wondering what other planets might exist around the stars in the night sky. Contemplating life beyond the solar system was relegated to science fiction. This all changed in 1995 when Mayor and Queloz1 reported the detection of the first exoplanet around a Sun-like star. The discovery of the gas giant planet, named 51 Pegasi b after its parent star, 51 Pegasi, came as a surprise. Gas giant planets, such as Jupiter, are located in the outer parts of the solar system. The prevailing theory was, and still is, that the formation of these planets requires icy building blocks that are available only in cold regions far away from stars. Yet Mayor and Queloz found 51 Pegasi b to be orbiting about 10 times closer to its host star than Mercury is to the Sun, Figure 1. One possible explanation is that the planet formed farther out and then migrated to its current location. Figure 1. The planetary systems of the Sun under 51 Pegasi a, in the solar system, gas giant planets, such as Jupiter, orbit far from the Sun. In 1995, Mayor and Queloz1 reported the discovery of 51 Pegasi b, a gas giant planet that is much closer to its host star, 51 Pegasi, than Mercury is to the Sun. The orbital distances of the planets are given in astronomical units. 1 or is the average separation between Earth and the Sun. b. The sizes of all objects are shown approximately to scale. The gas giant planet was not the first exoplanet to be discovered. However, the previous detections 2, 3 were of even stranger objects orbiting pulsars, rapidly spinning neutron stars, which are the collapsed remnants of hot massive stars. The discovery of 51 Pegasi b was the first to substantiate the existence of planets around long-lived hydrogen-burning stars that resemble the Sun. The bizarre character of a gas giant planet orbiting so close to its parent star engendered considerable skepticism about the true nature of 51 Pegasi b. Mayor and Queloz detected the planet through minute back-and-forth motion of 51 Pegasi, which seemed to indicate that a planet-mass object was pulling on the star. But this stellar motion, sensed by frequency shifts in the spectra of light from 51 Pegasi, had other possible interpretations. A lively debate ensued in the literature about whether pulsations of the star might be masquerading as a planetary signature for 5. The paper, a Jupiter mass companion to a solar-type star. This debate was put to rest in 1998 when the astronomer David F. Gray wrote a paper refuting his previous assertion that the stellar spectra were indicative of pulsations rather than a planet. 6. Further vindication came through the detection of planets similar to 51 Pegasi b, as other researchers combed their existing data for similarly unexpected planetary signals. 7. These highly irradiated giant planets have come to be known as hot Jupiters. In the 24 years since the discovery of 51 Pegasi b, about 4,000 exoplanets have been identified. See go nature.com/2jpcgtf. Other detection techniques have entered the scene, including the transit method, in which an exoplanet is revealed through the subtle dimming of its host star as the planet crosses the line of sight between Earth and the star. Hot Jupiters have continued to be discovered by the many exoplanet searches that are sensitive to large planets on close orbits. However, it is now known that such objects are intrinsically rare, orbiting only about 1% of Sun-like stars. 8. By contrast, planets known as super-Earths and mini-Neptunes abound. Such objects, which inhabit the size and mass gap between the rocky and gas giant planets of the solar system, were also a surprise to planet hunters, but seem to be commonplace in our galaxy. There is now good reason to think that the Milky Way contains more planets than it does stars. 9. Mayor and Queloz1's detection of 51 Pegasi b gave rise to a new field of astronomy. The ranks of exoplanet researchers have been steadily growing, by some counts now making up about 1/4 of the astronomy profession. See Go Nature.com/32 IMC4J. Incipient subfields include the study of exoplanet demographics and the characterization of exoplanetary atmospheres. 150 Years of Nature, an anniversary collection. This characterization has confirmed that hot Jupiters truly are gas giant planets, but ones representing what our own Jupiter would look like if it was suddenly transported 100 times closer to the Sun amid the scorching hot hydrogen-helium envelopes of these planets. Astronomers have detected trace amounts of steam, carbon monoxide and metal vapors 10 to 12. Such atmospheric studies could lead to the eventual characterization of exoplanets that resemble Earth. The future of the exoplanet field is bright. In April 2018, NASA launched a Transiting Exoplanet Survey Satellite, TESS, a space telescope that is just beginning to fulfill its mission of finding small transiting planets around the brightest stars in the night sky. These planets will be ideally suited for follow-up using NASA's James Webb Space Telescope, JWST, once it launches, to measure their atmospheric properties and compositions. Following on the heels of JWST, the European Space Agency has selected the Atmospheric Remote Sensing Infrared Exoplanet Large Survey, Ariel, Space Telescope to launch in 2028. Ariel will be dedicated to characterizing the atmospheres of a wide sample of exoplanets. These programs are paving the way towards the ultimate goal of potentially detecting the signatures of life on an exoplanet. This goal could most optimistically be achievable in the next decade, but more realistically will require a new generation of space and ground-based telescopes. 13. What is remarkable is that humans have come from discovering the first exoplanets to legitimately plotting out the search for life on these worlds in just a quarter of a century. Please subscribe my channel. Thank you. First exoplanet found around a Sun-like star in 1995. Astronomers detected a blisteringly hot Jupiter mass planet orbiting